All right. Well, this is another recording of what I've been building, vibe coding with originally the Unreal MCP project, but it's moved above and beyond just MCP. So what we're doing is building a simulator, and we can pull this over here. This is Unreal, and this is a world that I purchased, and um, you know, basically that's about it. Um, it's just characters, and I added a nav mesh. Big deal, right? Okay, so the two things that are new to this world are uh, I think in the last video I may have talked about this, but I added a camera character, or I don't know if it was a character, camera actor, C++ class that would take pictures when you asked it, and take pictures of what it's looking at. So this next step has been, well, let's try to build a simulator to where these characters can move around and take pictures and use LLMs. Two types of LLMs. One of them, actually LLM, multimodal, which is Gemini Flash, to take observations. So we can go in here, we can go in here, agents, Marion, observations. And these are the pictures that Marion is taking out of her eyeballs, which are the camera. And Marion's one character, the other character is Doofus. But there's these MD files and state files that Marion and or any one of these characters can use, and that's configured. Of course, this is in NPC Builder. That's going to change, and you can go into Marion and you can start configuring what model it's going to use. As far as the reasoning, and we have character, we have goals, rules, and this all gets put into the NPC. I'm sorry, APC. We don't use NPC anymore. They're AI PCs. So anyway, this is a app that can be used to configure them. But the other thing you do is you can connect the NPC with Claude. So Unreal Sim, click on it, reconnect. And then the other thing I do is I have what they call a handoff. I just told Claude to build a handoff based off of what's in the on the internet, uh, um, standard practices, so that every time I close a session, I say create a handoff. So as when I close a session, when I create a session, I just say read handoff. This is just a pro tip. And then, Claude will basically know where to start off from since then. So, the main idea here is that um, it's not just having Claude. Claude doesn't necessarily control the APCs. The APCs have this configuration, and they essentially do what the configuration says. Bigger idea is to have this whole web app be run as a separate simulation detached from Claude. Claude right now loads the NPC, which is the same code that this web app reads from, and that's something I'm going to be working on. So, anyway, the bigger picture is the APCs wake up and they read their, the LLMs are controlling them to a certain extent, and they wake up and they figure out where they are, and they decide what time of day it is, and what they should be doing. And even though there is a nav mesh in here, the other bigger idea is to make the APCs to where they're totally disconnected from any kind of 3D engine. And the way they connect to the 3D engine and 3D world is what I call a lizard brain, which is what, as humans, we have as well. And um, so the upper level LLM APC will, go about its life, and anytime it needs to, ask, take a picture and figure out where it is, it asks its lizard brain, which is essentially a device driver for the 3D world. And that's where the pictures get taken and sent off to, right now it's Gemini, excuse me, Flash. And, it's like, okay, describe the world, and that comes back. And then the LLMs can make decisions on, what they should be doing. So, what I've been debugging with all of this is, and again, this is a 3D world that I bought. I loaded in. The whole idea is that you should be able to load in your own 3D world and get some of this stuff working. And, obviously there's going to be some lizard brain tweaks, in the code, but, that's what you tell, excuse me, uh, Claude Code to do. So Claude Code goes through the code and fixes things, and it can see some of the things that are happening, and it can start and stop the simulations and things like that. And this is kind of a world where you're building, and you're fine, not to overload words, fine tune the way the prompts and the LLMs for each character work. Anyway, we got to it. This has been vibe coded for probably the last month or so, and the Unreal MCP was the first stab to where I integrated some previous code that does the excuse me, camera capture. So the camera capture part is kind of important for the LLMs to see the world. Anyway, the premise eventually, as you probably would want, is um, these APCs to interact with the world and have skeletons and look like whatever particular character you want, and have conversations and yada yada yada. And that's some upper level step that we're going to try to implement. The first thing I want to try to get done working right is as these APCs awake, excuse me, and figure out where they are in the world, what time of day it is, where should they be, go to those places, things like that. I kind of want all of that working so that people don't have to figure that out, download the project and try to get it working and figure that out for themselves. I want that part to be working, which is the very simple instructions. Load the world in that you want, you know, put the nav mesh in there, put these particular characters in the world, go to the web interface and define said characters, right? Define all of this and this blah blah blah. This will be growing, and then they can come back and they can run the simulation, either with the web page. Eventually I think I'll have some other tabs up here, which is the simulation page, and or you can do it from Claude Code via MCP. Um, some of the concepts that I'm working on as well are biological concepts, I think, that I've read about, which are grid cells and place cells. And what do I mean? Well, the world is obviously can be X and Y dimensions, and those, a hard coded, or maybe not hard coded, grid dimension can be created, for that world. And what is supposed to happen with these APCs is that as they wake up and they will literally look around, they will build what is called a place cell. This is a place. And place cells live in grid cells, but place cells, you can have many of them in a grid, and they can be constructed by a APC, and they can also be shared by other APCs. So that way, when we tell the APC to go to you know, this place, they can ask the lizard brain and say, well, where is this place? Well, it's in this grid. Okay, well, build me a path to that place, and then they go to it. So there's no hard coding or Python coding or any uh, coupling towards the APC. They ask their lizard brain, where is this? Just like your lizard brain in your skull, does, you know, makes you breathe and makes your heart beat and makes you do, helps you do all kinds of other things. But that place cell gets saved in the database, and then the APCs always know, oh, well, this is my place. I need to go over here. This is where I go to sell vegetables, this place. And you can't see the place, and it's probably going to be, it is saved in the database, but a couple of units outside of the APC, and there might be generic place cells, which is Don's Donuts. Well, where's Don's Donuts? Okay, well it's you ask the grid, uh, the lizard brain, where's Don's Donuts? and I think that's acceptable touch point to have kind of a mapping, world mapping service for the APCs, just like humans open up a map, right? And, a paper map, and they can go, or they go on the internet and they go, where's this? I think that's okay. But what we really want is the APCs to build the world based off their observations and rely on that as opposed to just calling into Unreal Engine, where's the XY coordinates for this thing, and things, things that will happen are, as these things, APCs move around, you could see these little, areas around the nav mesh. Well, you don't see one around that truck. That truck doesn't punch a hole in the nav mesh. And we want the APCs to be able to handle situations to where they see something and the VLM, visual language model, says, hey, there's a van right here. You know, we don't want the APCs to rely on a nav mesh per se, right? The whole idea is for you to be able to plug into this engine and, you know, uh, whatever 3D engine you're using, well, it might not have the equivalent of a nav mesh. Anyway, this is a 3D world that, it's boxes and roadblocks, whatever. But the next thing that should easily be able to handle is, well, you have a super high definition RPG world. And this system should be able to handle that because it's looking around in the world. It's taking observations. It knows where it is. It knows its goals. And it's like, oh, well, I need to go over here. And, if it needs to move out of the way, and or stay on the road or the path, that needs to come natural. So that's kind of where I'm at, trying to fine tune, no pun intended, the, some of it's LLM as far as the goals and the prompts, and then some of it is the lizard brain. And, I kind of want this to where, somebody can plop their own world in there and say, hey, map the world out, drop one of these NPCs in there, APCs, excuse me, and it just goes through the world and it's smart enough to know, if there's no nav mesh, no big deal. It can see a path, right? And it can walk down the path and, look around and, not go off in the weeds and do crazy things. So, that's the, stage one, which is to get the thing to do those. So I've kind of beat that into the ground, but grid cells and place cells. Place cells are memories that are either community or they are on a shared, uh, you know, as the NPCs, do it. And, then, we'll take the next step. So, anyway, there's a couple of things that are running all at once. This thing doesn't have to run the web interface, uh, but eventually it will. And the next thing, the main thing is that this Unreal app needs to be running so that at least the Claude can connect to it. So what we can do is Yeah, see, it's got questions. There's work we're working on, and that's the beauty behind the handoff. If you ever get that far. But anyway, we can say start sim. Oop, let me turn this on. All right. So this is running. I'm just moving up to where I can see what's going on. So Marion, which doesn't have a good skeletal mesh, but she has a camera. She's sitting right here, and this is Doofus. And what's going to happen is Marion's going to wake up, and where am I? Who am I? Blah blah blah. And the lizard brain is going to say, "Oh, well, you're in this place." So if Marion woke up and she wasn't in a place, then she would create a place and she would look around with the observations. But since she's already in a place that she's already been to and she already has observations around here, she should just stay, you know, still. Because that's what she does. She sells vegetables. Doofus, on the other hand, you know, he should go around and explore the world. Yeah, I'm waking up, heading now. I'm already at my post. So the LLMs are working, meaning they're reading, the goals and, when they wake up and what they should be doing. Now, there's a little delay in here, and I don't know what it is. It could, but it's going out, and it actually, Doofus should be creating places as it goes. And you can't see the grids. But Marianne just sits there, which you might think, well, that's kind of boring, but that's kind of the way it is. But what you really want is Marianne to see Doofus and then, say something or whatever, which she doesn't. And then Doofus just keeps, kind of going. And I don't know why, uh, with these ticks, why it does, Doofus doesn't keep moving, but he'll move and then he stops and he moves. So Doofus is exploring. I'll do an F1. And then we say, stop sim. And the same functionality I want to have on the web page, which is I can start and stop the sims, and I can also look at a little bit more detail of what's going on here. There is another log file. So Claude's asking, what did you observe? But this is kind of the debug part, the building, the feature building part. And that's, I want to have this sim to run it where it will run standalone. See, Claude owns that MCP server. It owns the lifetime of the MCP server. And that means you can't delete log files. You can't do all of this stuff that you think you'd want to do because Claude owns it. So that's the next thing that I want to try to figure out. So we kill Claude, and we can kill this. And part of the code will reset the states and then reset the where the NPCs are in the world, but it won't reset the place cells. And we'll have to have a little bit of code. We tell it to do that. So Anyway, it's not just an MCP server, it's a simulator. And, Unreal, they're going to have their own, they already have their own MCP server. And that's not what this is. And actually, some of the API calls I might just rip out and make Claude code when it's connected to make direct API calls, to the engine. So, I say engine, there's C++ code that's uh, running in Unreal Engine, and then there's a Python server that talks to the Unreal Engine, and it also acts as an NPC server, and it acts as a simulator. And let's see, the GitHub. GitHub is where is it? Where's the browser? Oh yeah. So the GitHub is here. Unreal Sim, and it should go into details on what to do to set up. It's built off of Chow Dashu's NPC, but Google, or I'm sorry, um, Unreal already has a new NPC, so it's that's not that important. I don't know how much up to date this is. I don't know why this character's in there. This is just typical vibe coding, but it seems like it's relatively close. Again, to run this project, you're going to have to already know how to set up a C++ Unreal project. Visual Studio Code 2022, and with game dev uh, dependencies and all that added. That's a whole other video. That's a whole other thing that you're going to have to do to get close, because this has C++ code that you have to build. And so there's that. Um, then you're going to have a world that you pull in. You're going to have to be relatively savvy with Unreal Engine. Hook up a nav mesh. But then after that, you should be able to drag and drop the blueprints, onto the map, and, start experimenting with things moving around. But anyway, so there's, it's a big learning, this isn't just an executable that you download and you run. You have to know how to do some things, and I go into some details on how to do it. It's expected that you already have Claude Code installed. It's expected that you already know how to hook up MCP servers. I go into a little bit of detail on that, but some of it is not hand holding. But eventually it will get cleaned up to where it's easier for people to get involved in. The Like I said, and what I'm going towards is having APCs that can look at the world and navigate through the world and be controlled by simple prompt goals, and not a lot of hard coded, touchy feely with the underlying 3D engine, like a nav mesh, you know, and those are things that I want to try to, you know, abstract away. So that way anybody that is savvy enough can get this thing running, and they pull in an RPG game, and then they totally build out a 3D character, and it has the ability to walk around and see things, and not use the conventional Unreal Engine nav mesh and AI blueprints and all that stuff, which you can very easily do. Well, I say easily if you totally understand Unreal Engine. I'd rather have these things, go through the world and have conversations and things like that, with some of the other AI papers that are out there, which is Voyager and Simulacra. But different they use 2D, browser engines. I want to emulate what they do to the best of my ability, but in a true 3D world, even though this is kind of a lame, Roblox world, but it should work no matter what. Anyway, that's where I'm at. That's where the project's really going. Unreal MCP is, that's out there, and big deal. I mean, it's cool, but it's like that's not where that's easy stuff. So we're getting into some serious, in my opinion, serious AI orchestration with visuals, and I think that's gonna, make the world come alive. That's all I got. Thanks for watching, and let me know what you think.